This is day 26 of Unit 7. We started today with a warm-up, so take a moment, try that. So if I rewrite these so they have the same base, I get that, and then setting the exponents equal, and solving, I get negative x equals 6, which means x equals negative 6. Okay, now we did that today to remind you how to do those type of problems because we did these today in class. So if you want to copy that into your notes. So what I asked students was, can we solve this one here the same way that we just did in the warm-up? The answer is no, because we can't rewrite 2 and 1.04 don't share a base. So I can't use that approach. So what I will do instead is use what we've been doing the last several days, which is I'm going to use logarithms to help me solve this. And also, if you recall earlier in the unit, we guessed and checked to solve this. We won't be guessing and checking ever again because now we're going to use logarithms. So I'm going to take the log of both sides. And when I do that, that allows me, hopefully you notice here on the right-hand side, that I can now use the power property. And I'm just going to copy the left side. So now I have, I can see that to get x by itself, I just have to divide by the log of 1.04. So if I want an exact answer, x is equal to the log of 2 divided by the log of 1.04. That's my exact answer, and then you can just type that in the calculator to get the decimal approximation, which is approximately 17.67. Okay, so then we tried example 1b. So again, I asked, can we rewrite with the same base? A couple students thought maybe base of 5 they share, but I can't take 5 to a power to get 145. So once again, I'm going to take the log of both sides. And use the power property to bring the x down front. And I am trying to solve for x. I'm going to divide by the log of 25. And when I do that, I have exact answer here, log 145 divided by log 25, and that gives me approximately 1.55. So that's how we do those. Okay, so then we tried this one, and I said, well, can I do the same thing? Can I just take the log of both sides? And hopefully, if you're looking at that, you're realizing, no, I can't take the log of both sides yet because this is not in exponential form. In other words, I need to get rid of the 4 and the 2 first. Then it'll be 1.5 to the x. It'll be in exponential form. So then I can take the log of both sides. So let's subtract 4 and divide by 2. Now it's in exponential form, so now I can take the log of both sides. Okay, and now that I've taken the log of both sides, I can apply the power property. And then I can divide both sides by the log of 1.5. And I'm getting x is equal to, there's my exact answer, the log of 4.5 divided by, actually, the log of 1.5. And that's the exact decimal approximation is 3.71 approximately. Okay, now I just want to point out, you do need to show these steps that I'm showing here. A lot of times students will want to go from 1.5 to the x equals 4.5. They'll want to go right from that to x log 1.5. And I explained that this step here is essential. You have to show it, even though it might be a pain. You have to show it because you can't apply a log property. The power property is a property of logarithms. You can't apply that property to something that doesn't involve any logs. So I can't go right from here in this step, which is no logs, to this step, which is x times the log of 1.5. I can't apply a property to something that doesn't involve logarithms when the property is a log property. So you have to show that step there of taking the log of each side, then you can apply the power property. Okay. Next, we did this one, so I think I just gave them some time to work on it, and then we went over it, so maybe you want to pause the video and try it. So I have exponential form. I'm going to go ahead and take the log of both sides. Okay, now some students realize the log of 10 is equal to 1. If you realize that, great, you can write it as 1. If you didn't notice that, then left it as a log of 10, that's fine, it doesn't matter. But the log of 10 does equal 1. Hopefully you realize that now, because 10 to the first power equals 10. But then I'm able to, bring that 3x plus 4 down front and multiply it. Now, when you bring that down, be absolutely certain you put the 3x plus 4, the binomial, in parentheses. If you don't, it might seem like, oh, what's the big deal? It's just parentheses, but it makes a big deal because without the parentheses, this reads as 4 times the log of 5 and then add on 3x. I don't want to do that. I want to take the binomial 3x plus 4 and multiply it by the log of 5. So you need the parentheses. Okay, so now that I have that, I'm going to divide both sides by the log of 5. And again, if you still have this as log of 10 divided by log of 5, that's fine, either or. So I'm going to subtract 4 and divide by 3. Now I'm going to write that as in exact form first, 1 over the log of 5, and then I subtracted 4 and I divided by 3. That's my exact answer. And then I'm just going to type that in the calculator to get the decimal approximation. And that is negative 0.86 approximately. Okay, so next we tried this one, and this one is E, and we have talked a couple different times now about E. You hopefully remember E from our compounded continuously formula, PERT. So it was used there, and we know that it's a number. We hopefully remember that it's called Euler's constant. And the last thing that we talked about, the most recent thing we talked about with E, is that when we have a natural logarithm, ln, we did a couple of those with the log properties. When we have ln, that is just the natural logarithm, meaning that the base is e. So e, that number e from PERT. So I'm going to solve this one in a similar way to the previous ones. I do see an exponential equation I'm trying to solve for the variable exponent. So I am going to take the log of both sides. However, I'm not going to use log base 10 because this isn't using base 10. This is using base e. So I'm going to take the natural log of both sides. And the reason I'm taking the natural log of both sides is, again, because this has a base of e. And I know that e is the base for a natural logarithm. So I'm going to write ln, or natural logarithm, of e to the x minus 4 is equal to the natural log of 12. So doing that allows me to use the power property. Remember, even though it's a natural log rather than a log base 10, I can still use the power property. So I'm going to bring that x minus 4 down front. And I have that. Now, a moment ago, in the last problem, I said that the log of 10, some people in class realized that that equaled 1 because 10 to the first power equals 10. Well, the ln, or natural log of e, we also can simplify that. So remember, I said that the natural log's base is e. So e to what power equals e? Again, that equals 1. So the ln, or natural log of e, is equal to 1. So the nice thing about that is this just drops out, and that equals 1. So I have 1 times x minus 4, which is just x minus 4. So very quickly we're able to solve that by using the natural log rather than log base 10. So then I can add 4. And that's my exact answer. And then if I need the decimal approximation, I can type the natural log of 12 in my calculator, add 4, and get my answer of approximately 6.48. Okay, so let's try one more. This is in your packet on page 23. It's problem number 5. So the first thing I can do is, or the first thing I should do is get rid of that 64. So I'm going to divide. And then hopefully you're noticing after I've done that, 16 and 64 share a base. You can either use 4 or 2. So this one I could do like the warm-up. I could rewrite so that both sides have the same base. If I want to do that, I can, or if you like using the log, taking the log of both sides like we've done in the other problems today, you can use that technique as well on this problem. So it doesn't matter, either technique will work and you'll get the same answer. Either is fine. I'm going to go ahead and, since we haven't done very many today with getting the bases the same, I'm going to go ahead and do it that way. So I know that 1/16 is 4 to the negative 2, so I'm going to replace that, or replace 1/16 with that. I know that 4 cubed is 64, so 4 to the negative 3 power is 1/64. So now I'm going to go ahead and distribute my negative 2 to the negative 3v minus 3. So that gives me 6v plus 6 and 4 to the negative 3. So then I'm just going to set 6v plus 6 equal to negative 3. So 6v equals negative 9. So v equals negative 9/6, which simplifies to negative 3/2 or negative 1.5. Okay, and that's my final answer. And again, you could use that approach, or if you had taken the log of each side, you would also get v equals negative 1.5. Okay, so this assignment, oops, that's not what I wanted to do. Whoops. Okay, I guess we did. I don't think we did that one today in class. We'll do that next class. So your homework, this is going to be your homework. You can do that for next class.